agricultural landscapes of West Africa. So at this point, I'll leave it up to Chima to take it over. So Chima, over to you.
All right, I'll just share my screen now. Yes, can you see my screen? Good afternoon, everyone.
Yes, Chima.
All right, my name is Chima Iheaturu. I'm a PhD student at the Institute of Geography in University of Bern, and I'm working on sustained forest projects. I'll just give a bit of a background about myself. I'll start with my work experience. First, I was an intern at the Office of the Surveyor General of the Federation in Abuja, Nigeria, between the years of 2013 to 2014. And then I went on to, work as a research assistant at the Department of Surveying and Geoinformatics in Imo State University between 2015 to 2016. And then as a graduate surveyor under the National Youth Service Scheme of Nigeria between 2016 and 2017. And in 2018, I worked as an assistant surveyor for CBEC Eco Engineering in the UK. And then I also worked as a GIS stroke drone mapping specialist for MV Geospatial in Nigeria between 2019 and 2020, and as a GIS and database manager for Wildlife Conservation Society between 2020 to 2021. My background, I hold a Bachelor of Science degree in Surveying and Geoinformatics from Imo State University, and a master's degree, from the University of Glasgow in geospatial and mapping sciences. And of course, I'm currently a PhD candidate at the University of Bern in Switzerland. I started off in November 2021. Yes, I'm going to do a short presentation on my PhD proposal, actually. And I'll be talking about, the background, the project working title, the research objectives and corresponding research questions, my proposed methodology, and I'll also talk about potential papers, scientific significance of the project, and I'll also give a brief overview of timeline and milestones, and then finally I'll talk about my next steps. To give a bit of a background, what has happened, agricultural, the forest landscapes, within West Africa have undergone deforestation, mainly due to small-scale agricultural expansion. This leads to fragmentation of the once contiguous Guinea-Congolian rainforests. These forest patches, although they are small, they still provide crucial ecosystem functions and also serve as, habitats for biodiversity, and are also important, carbon sinks, and they also contribute to diverse ecosystem services and functions, and they also sustain a vast number of livelihoods. Forests in general, they continue to decline at alarming rates, based on the publication by Global Forest Watch. And we can see on the map, of course, this is the tree cover map based on the Hansen data sets. And we can see the red patches, indicating the forest cover loss between the year 2020 and the year 2000 and 2020. From 2001 to 2000.
Chima.
Hello.
The slide is not moving. Really? Are you still on the first page?
No.
Yeah.
You can't.
Yeah,
Can you
okay,
see?
right now, yes, right now you can see. So we are seeing the PowerPoint and the slide, so you can see it now.
Oh, okay.
So I think you can go back to the background again. Sorry for that.
Okay, sorry about that as well. Let me just. Can you see this now?
Nope. Okay. Move. Maybe it's in the form of animation, right?
Yes.
Okay, so I think we can see it now.
Okay. Okay. Yeah. So sorry about that. Like I said, agriculture-induced deforestation, has led to fragmentation of, the once contiguous Guinea-Congolian rainforests. And this leads to, having pockets of forests, within agricultural landscapes. Now, these forest patches, the forest patches that remains now, they contribute crucial ecosystem services and and functions, and they also serve as habitats for biodiversity, and it's important to note that the forests, continue to decline at an alarming rate. And of course, they ought to be sustainably managed if, they are to persist. If you look on the map on the right, you see, a map based on the Hansen data set, indicating the forest cover as at 2000, as at the year 2000, and then the associated forest cover loss between 2000 and 2020. Looking at the map, you see the red spots on it indicating the forest loss. So between the year 2001 to 2020, Togo, lost about 613 square kilometers of tree cover. And this is equivalent to, about 1.08% decrease in the tree cover since the year 2000. While Benin, between 2001 to 2020, lost about 410 kilometers square of tree cover. And this is also equivalent to a 0.353% decrease in the tree cover since 2000. While Nigeria, between 2001 to 2020, lost about 10,512 square kilometers of tree cover. And this is equivalent to 1.15 decrease in the tree cover since the year 2000. And Cameroon, between 2001 to 2020, lost about 15,356 square kilometers of tree cover, and it's equivalent to a 3.28% decrease in the tree cover since the year 2000. However, in the year 2015, studies conducted by various researchers, posited that, countries such as Benin, have a medium biodiversity intactness, while Togo also have a medium, about 46%. And then Nigeria has a low, biodiversity intactness, while Cameroon, despite the 3.28% decrease of tree cover since 2000, still have a high biodiversity intactness. What this goes on to tell us is that we need to, in as much as, we've had this forest loss since 2000, since the year 2000, we still need to, sustainably manage the remaining forests, so that they can, persist. And that brings us to my topic. So basically, I'll be looking at a multi-scale modeling of spatio-temporal dynamics of forest patches in the agricultural landscapes of West Africa. Because I'm looking at this topic because I know that understanding the spatial and temporal dynamics, and including the factors that are involved, is very crucial for identifying ways to ensure that the conservation and the continued contribution that these forest patches provide to human livelihoods are sustained. To achieve this, I have several objectives. My first objective is to conduct a systematic review of remote sensing-based forest mapping and characterization in agricultural landscapes. Within these objectives, I'm asking a series of questions. The first is, what is the state of the art of remote sensing of tropical forests and forest patches in the agricultural landscapes? The next question is, which sensor systems in combination with which platforms are particularly suitable for mapping forests and forest patches? The next question is, which algorithm and new processing approaches are required to obtain high quality information for the modeling of forest agriculture mosaic landscapes? The next question is, what are the current spatial, temporal, and spectral limitations of remote sensing change in tropical forests? And then the last question is, which tools will we have in the near future to study these processes? And under this first objective, I have, two other sub-objectives. One is to identify and map forest patches in the agricultural landscapes of West Africa using remote sensing approaches. Under this, I'll be asking, what are their features, as in the features of the forest patches? Example, the forest age, the size, the connectivity, the proximity, the height, the health, and the continuity. My next sub-objective is to develop a method for assessing the accuracy of spatially non-contiguous forest patches for West Africa. And then under this, I'll be asking the question, how reliable is this method? And can this method be used to validate other spatially non-contiguous remote sensing data, other thematic maps? My objective 2 is to analyze the spatio-temporal dynamics and conditions of forest patches at multiple scales. Under this objective, I'm asking, how have the forest patches changed since the last quarter of the 20th century, that is since 1975? What is the pattern of change in the forest patches? What similarities or differences exist at the various scales? What are the main factors affecting or driving the spatio-temporal dynamics of forest patches in the agricultural landscapes of West Africa? And what role do these factors play and how significant are they? Under the first objective, I also have two sub-objectives. One is to map the structure and condition and biodiversity of selected forest patches at a fine scale using a combination of unmanned aerial vehicles and terrestrial laser scanners. Under this sub-objective, I'll be asking the question, what is the current situation of the selected forest patches in terms of the forest health, the socioeconomic and sociocultural situation? Is it a sacred forest? Is it a rapidly diminishing fragment? And how does it compare with satellite image derived conditions observed in the objective 1A? Then secondly, I intend to map the spatially explicit, conduct a spatially explicit modeling of ecosystem services of the forest patches. Under this sub-objective, I will be asking, based on the models, what are the ecosystem service outcomes for local stakeholders across the project area, which is Togo, Benin, Nigeria, and Cameroon? And then how do the ecosystem services outcomes change according to agricultural and forest-based scenarios at regional and at local scale? My third objective is to establish the nexus between the socio-ecological systems and the spatio-temporal dynamics of the forest patches. Under these objectives, I'll be asking the question, which components of the socio-economic and socio-ecological systems, such as land use, governance arrangement, markets, population, climate, etc., drive the spatio-temporal dynamics in terms of persistence, expansion, and decline of forest patches in agricultural landscapes of West Africa. And then I have one sub-objective under this third objective, which is to modify or develop agent-based or dynamic simulation models comprising land actors' use, management, and governance of forest patches, and then link it with a GIS. Here I'm asking, how are forest patches likely to evolve in the future, considering the different interacting drivers, such as the land use, the governance arrangements, the markets, the population, the climate, and then can these models be applied, to other regions of Africa and the world in general? Then it takes me to my methodology. The framework of my project is aimed at applying a landscape-centered and a people-centered approach. I chose this because we can't actually disentangle the forest from humans. So any model or any approach should be, people-centered, and it also, of course, it may change, as the landscape changes. So it's also important that the approach or the framework is landscape-centered, and of course, this will involve, both qualitative, quantitative, and modeling methods, which will be used, to capture biophysical, sociocultural, socioeconomic, institutional interactions, and scenarios that affect the sustainable management of forest patches. And so this gives us three main approach. The quantitative, of course, these are quantifiable metrics, and I intend to use remote sensing techniques to achieve this, such as modeling the studying the land use, land cover changes, and also the condition structure, and dynamics of these forest patches. And under the qualitative, of course, these are descriptive measures. I intend to use semi-structured interviews, valuation focus groups to capture place-based dimensions such as ecosystem outcomes. And then the third, which is the modeling, it's kind of like an imitative approach, to conduct scenario analysis and to perform dynamic simulation. This is to analyze, the possible outcomes of the different arrangements, whether governance arrangements, whether institutional arrangements, whether socioeconomic, socio-ecological arrangements, to see how it impacts the model or the outcomes of the project. That takes us to the conceptual framework. Under the conceptual framework, of course, like I explained earlier, it will start from the remote sensing-based forest patch inventory. This will be conducted at the regional scale, and at the landscape scale, we have pressures such as climate change, land use, land cover change, and other drivers that lead to this forest patching within agricultural landscapes. Then I'll study, the forest patches based on the spatio-temporal dynamics and conditions, and also the structural characterizations of these forest patches. Then I'll conduct a spatially explicit modeling of ecosystem services, alongside stakeholder perspectives of, the spatio-temporal dynamics, and, just studying interactions with the socio-ecological systems. And this will take me to the modeling, the dynamic simulation modeling, comprising of land actors' use, management, and governance of forest patches, and that will lead to, the sustainable use of forest patches. So in the end, I hope that the project will lead to strategies for policy and practice, and then also disseminate knowledge-based products such as tools and guidelines towards the sustainable management of forest patches. And of course, the project, is supposed to lead to, of course, I'll have results and publication. So I hope that, I'll have, several publications and results from this study. And the entire framework operates at a multiple spatial, functional, and temporal scale. So here is an overview of my methodology. Yeah, starting from a systematic literature review of remote sensing of tropical forest and forest patches, and then leading to the remote sensing-based mapping of forest patches in agricultural landscapes of West Africa. And already we've conducted a spatial inventory of tropical forest patches in West Africa, and then there were some limitations in terms of resolution. And I hope that my remote sensing-based mapping of forest patches would, solve this problem associated with the resolution. Then we'll do a selection of sample sites for in-depth analysis. And of course, we're going to collect data and do some ground truthing. And at the same time, we'll conduct a validation of, because remote sensing based product ought to be validated if they are to be used, for decision making processes. So I'm going to conduct a validation of the remotely sensed forest patches, and then study, the land use and land cover dynamics and the conditions of these forest patches at multiple scales, and also conduct a spatially explicit ecosystem services of forest patches. The forest patches identified in the spatial inventory that was conducted, and then leading to a study of the stakeholder perspectives on, spatio-temporal dynamics of forest patches, and then an analysis of the socio-ecological systems and spatio-temporal dynamics of the forest patches, leading to a GIS-based dynamic simulation modeling of land actors' use, management, and governance of the forest patches. The method I hope to, my methodology is grouped into, 4 classes basically. For the first one, it's geospatial analysis and mapping operations. This aspect will be done using, QGIS, ArcGIS, Google Earth Engine, Digital Earth Africa Sandbox, the ODC, and including R as well. And then the UAV mapping and terrestrial laser scanning mapping of forest structures will be conducted, to study the forest conditions and biodiversity. And this will be done using a LiDAR drone, the DJI Zenmos L1, that will be mounted on the Matrix 300 RTK UAV. And then the terrestrial laser scanning will be done, using the Regio VZ 400i. The other aspect is stakeholder analysis and stakeholder views. The stakeholder analysis will be done, using this tool in Excel. It's a free tool in Excel to identify who the stakeholders are, and what role they, or what level of authority they have. While the stakeholder views will be captured through simple yes or no or Likert scale questions, and this can be easily implemented using the Kubo Toolbox application on an Android device. And then lastly, the dynamic simulation modeling will be done using a free tool called the Clumundo, to conduct the spatially explicit modeling within the project. On my right is, just a snippet of what, the UAV mapping can produce. I can actually get, looking at it, I can get very many layers of data, from point cloud to, tree metrics, such as canopy height and tree density, which can inform my forest condition and biodiversity mapping. This is just an overview of my project requirements, which I've mentioned within the scope of my presentation. Basically, software, hardware, and data, basically. Yes, I hope as part of the requirements for a PhD within the University of Bern, we are supposed to have at least 3 main authored publications and 2 co-authored publications. So here is an overview of my proposed publication. First, the first paper will be on an integrated method for validating spatially non-contiguous remotely sensed forest patch data set for West Africa. And then the second paper will be a remote sensing of tropical forests and forest patches. And this is a systematic review. This will be a systematic review paper. And then the third paper is fine scale mapping of tropical forest patches, patch structures, conditions, and biodiversity in West Africa. And then the fourth paper will be like a multi-scale spatio-temporal dynamics of tropical forest patches in West Africa, assessing this spatial heterogeneity of ecosystem services and stakeholder perspectives. And then the final paper will be a GIS-based dynamic simulation modeling of land actors' use, management, and governance of tropical forest patches in West Africa, insights for sustainable land management. Now, one may wonder why a systematic review paper is not the first. It is just depending on, this is based on, of course, I'm currently working on the systematic review, and but it takes a longer time. So my expected time of completion will be before this paper, which I'm working on concurrently. So that's why you have the validation paper as the first paper. Just an overview of my work plan, my 3-year work plan. Like I mentioned, because of the time I joined the project, we already started mapping and conducting a forest inventory. And so with that data, we needed to validate it. And part of my project will be to validate the data. And that's why the first paper will be working on the validation of the remotely sensed forest patch data set. And of course, I'm working concurrently on the second paper, which is the systematic review paper. And within these, I have, for now, I have one abstract that I've submitted to the EGU conference on the validation paper, the first paper. And I hope to present my results in this European Geoscience Union Congress. Then, of course, I'll have to do some field data collection for like 6 months, and at least every year, as advised, I will have a committee meeting, which is like a time to refine project plans. And throughout the project, I'll be working on, the third paper after my field collection, the third paper, the fourth paper, and the fifth paper. And of course, I'll do a synthesis, of the project, and because my PhD is a collection of papers, so I'll do a synthesis to make it seamless and like a story base, starting from the systematic review down to the GIS and GIS-based modeling paper. And of course, I'll write the thesis, and I hope to graduate in at the end of 2024. In terms of scientific significance of my project, the project is significant for for 5 main reasons that I've identified as at now. The first is working in these 4 countries will provide a foundation for long-term comparative research into sustainable agriculture and of course forest governance, basically in West Africa and Sub-Saharan Africa in general. The research, will also provide, one of the first studies to have to use a fusion of UAV based data as well as terrestrial laser scanning data, to assess tropical forest structures, conditions, and biodiversity in West Africa. And of course, the outputs of this project will be made available and accessible, and this will, of course, bridge the data scarcity gap that we have within the region. The findings will also inform, relevant stakeholders, at all levels about the need to sustainably conserve and manage the remaining forests that we have, in this region. And finally, I hope the research, would, of course, I believe that the research will initiate collaborations that can foster the conservation and sustainable use of forests and forest products in general. And this is kind of an overview of my timeline. I started the PhD in November, and so far I'm working on my proposal, and I've also, done a registration with the International Graduate School, and in April, I hope to have the first draft, at least, of my first paper, and then in May, I hope to have completed my PhD proposal and have it submitted and sign the doctoral agreement of the school. And in August of this year, I hope to submit my second paper on systematic literature review. And in September, I'll embark on my field data collection, which I hope to complete in February of 2023. And in June of 2023, I hope to have completed, my third paper, and then the fourth paper in October of 2023, and then the fifth paper in February of 2024. So between February and October, I'll do some, I'll work on actually finalizing my PhD and writing of my my thesis, which I hope to submit in November of 2024. As per my next steps, I intend to incorporate feedback. I've been getting feedback from both my supervisors and senior researchers, and I hope to incorporate this feedback and update my my proposal. So I also work on developing an algorithm or modifying an algorithm to detect forest patches. I'm looking at using the Sentinel data to achieve this. Then I'll work on a detailed fieldwork plan, before embarking on my field data collection. And then I'll discuss my strategies of systematic review with my supervisors, and look for potential researchers that could potentially collaborate on this review paper. And finally, to write a first draft, before April on my first paper, which is on the validation strategy for the forest patch data set. Thank you very much. And I apologize for, I'd done this presentation in like an animation mode, but due to technical difficulties, I couldn't do that. So I apologize for the whole issues that arrived. So thank you.
Thank you very much, Chima, for the presentation. Really appreciate it. At this point, please, if anyone has any question for Chima during his presentation, you can actually turn on the mic, and if there is any question you would like to ask Chima on it.
Hello, Edward.
Yeah, Ben.
Yeah, thanks for the opportunity. Chima, that was a very elaborate presentation. Thank you so much for that. It looks really interesting to see a kind of study that would look at forest patches across the West African sub-region. And I'm really optimistic that this is something you can do. And I'm really looking forward to the results of your study. Well done.
Thank you very much.
Thank you, Ben. All right, and I think Chima will put his contact in the chat. So in case anyone wants to reach out to him for further collaboration or maybe further discussion, you'll be able to do that and have this conversation with him. Chima will also be implementing the Digital Africa resources like this.
Sorry, I'm back again. Chima, I missed the earlier part of your presentation. I joined in a bit late. Apart from Togo, which other countries are you working in?
Okay, I'm working on Togo, Benin, Nigeria, and Cameroon.
Oh, okay. You didn't choose Ghana. That's okay.
Okay.
Okay, Stella.
That's a good presentation, Chogo. I just wanted to ask one question because you're looking at forest patches. Are you working with different, can you hear me?
I can hear you.
Are you working, how are you going to be able to identify the different types of agents that influence the forest patches? Is it something you're going to look into, like insects, disturbances, or like, for example, forest fire? What are the types of agents you're going to focus on? And my second and last question is, are you also going to use any look at mortality rates that have been occurring in the past few years based on the different types of forest or different types of agents that are influencing the forest patches? Thank you.
Okay, can I go ahead and respond to the questions right now, Edward?
Yes, Chima. Then after
okay.
Backwards ask a question. So Chima, please, you can respond to the questions.
Okay, so I forgot to mention, the project is it's a sustained forest project, and it's an interdisciplinary project. So we have 4 teams. One of the teams will be looking at ecology and conservation of these forest patches. Another team will be looking at livelihoods, and ecosystem service delivery, within these forest patches. So, and then the third, of course, will be looking at governance arrangement that works. So my own project is looking at just kind of the remote sensing based approach, looking at the entire study at a holistic level, and conducting modeling, basically modeling of several arrangements, that can foster the sustainable use and management of these forest patches. So to answer your question, in terms of agents, the PhD on studying the ecology and conservation will be looking at several aspects, and I suppose this will be inclusive. And then the other one on the mortality, I'm not sure if we are looking at that, but I believe the PhD working on the livelihood and ecosystem valuation would want to look at something related to that. I don't know if I answered your question.
Thank you so much. It's a good study.
Thank you.
Chima. Chima.
Hello.
Yeah.
Good. This is a quick one. Are you somebody already working in the field of remote sensing and modeling?
Yes. Yes. I have a background in remote sensing.
Okay, awesome. So my quick question is, in your literary model, you can use directly or maybe tweak a bit to give you what you want, or you are going to create a model from scratch?
Sorry, come again.
Okay, so what I'm asking is, in your literature review so far, have you identified any model of the sort that can do what you want, or you are going to create a model from scratch?
At the moment, of course, what I intend to do is to either modify or develop. But it seemed like because I'm still looking at some studies, in terms of modeling. The modeling aspect now is just basically, spatially explicit modeling. And this modeling is just based on the first is the ecosystem outcomes, conducting a model of that. And someone has done something similar, but I'll just tweak it to make it a bit spatially explicit. And in terms of the governance arrangement, and other land use actors that could foster sustainable use and management of forest patches, I intend to use the Clumundo. It's a spatially explicit modeling tool, and I think it fits nicely to what I intend to work on.
All right, awesome.
Thank you, Ben. Bako.
Welcome.
Yeah, Edward. Can you hear me?
Yes,
yeah, I can hear you.
So Chima, thank you so much for sharing this this thought. So I have some 2 or 3 questions for you. The first one is about the area of interest, because talking about West Africa. So I have one concern about the countries that I hear, because I'm asking myself if Cameroon is part of West Africa. This is my first comment. And the second one is a suggestion about the countries that can be covered. I hear someone suggesting Ghana. Yes, Ghana is in West Africa. And we have already one initiative conducted in West Africa. And I want to share the link with you. It's about the WABIC project, WABIC.
Okay.
And the colleague from Ghana knows that it is a very good initiative that was conducted in West Africa, covering some key countries where you have forest and biodiversity. So I shared the link in the chat with you to see if it's possible to change something, or if not, okay, no problem for that. But the third one is about the Digital F Africa initiative. As you know, we have tools, we have a platform. I want to. The question is, are you aware about what the Digital F Africa is doing in Africa? because we have platform, we have script, we have everything. So my question is, what do you think can be suitable for your research about what we are doing through this initiative? Thank you so much.
Thank you for your question. To start, you talked about why Cameroon was included in the study, since Cameroon is not West Africa. To answer that, or why Ghana wasn't included, since Ghana is in West Africa. To answer that, our focus, we're looking at the pressures that this forest patching is causing, in contrast to the Congo Basin. The Congo Basin is, the second, largest remaining forest and contiguous forests. And we're looking at the last, the last 4 countries. We are limited by time and we're limited by budgets, so we can't look at all the countries within West Africa. So we're looking at the last 4 countries, within the Guinea-Congolian rainforest and Guinea forest. So that's the justification for choosing these 4 countries. And then for the WABIC, I'll need to have a look at it and see if I can. I'm going to drop my email within the chat, so that we can, maybe you can reach out to me or something via email, so we can have a discussion on this. And lastly, in terms of, I'm also looking at, of course, exploring possibilities of using the Digital Earth Africa sandbox, to write algorithms, or either modify, existing algorithms, or tweak in any way to suit my my goal in terms of identifying forest patches that meet these criteria that I have. Thank you. I don't know if I've been able to answer your questions.
Yes, Chima, thank you. And Edward, can I ask the last one, please?
Yes, but I think the time is.
Yeah, thank you, Chima. So Chima, the last question is about the definition of the forest itself. Because from our experience talking about the forest, we didn't define the forest the same way in the countries. So perhaps what can be forest in Ghana or in West Africa and all those countries, it's not the same. That's why we initiated one study or with FAO to harmonize the classification system that are used or will be used in West Africa. So yes, we came with one classification using LCCS, land classification system, 3 of FAO, to harmonize all what our countries are doing. So for that, our focal point here at Agreement is Mansour. If you want to know exactly what we did through this initiative, Mansour can share one publication that we did or we are trying to finalize. So this is in terms of contribution. If not, it's not so easy to talk with the same voice about the forest in our countries. I don't know if you are aware about this. Thank you.
Yes, thank you for your question. In terms of the definition of a forest, I think I omitted that in my presentation. Maybe it was at the earlier stages when I was having some technical difficulties with my presentation. But yes, the forest patch, now we are using the FAO definition of what a forest is. That is, it is an area that is larger than 0.5 hectares with trees higher than 5 meters, and canopy, of about 10%, canopy cover. So now, within this definition, what we're looking at basically is a patch of forest, which is like at least 0.5 hectares within agricultural landscapes, that has remained stable over the last 20 years. So we are looking at this forest patch would have a forest cover at least of 10%, and then a tree height of a minimum of 5 meters. And of course, we're looking at the consistency now, which is 20 years. So they must have remained, for at least 20 years. And this is, from the FAO definition.
Okay, so Chima.
Thank you, Chima.
Thank you, Chima. Chima, this is the last question, and I think it's a straightforward one. If you can, it's from Mohammed. Say for tropical forest, patches could recover fast over time if there is a possibility of excluding degradation agents. Is your study looking at these very detailed pathways, or just a focus on the status? Can give us quick answer?
Is there a possibility of excluding degradation? Well, basically, we are looking at we are still, the part of the study will be to understand the drivers, the drivers that is causing these forest patching. We already know that climate change is a major driver, and of course land use change, this is something that is already known, is a major driver that is causing this forest patching. But land degradation basically is not something we are looking at in particular. But I mean, whilst conducting the study, if we find it necessary, then we might include it in our focus.
Okay, so thank you, Chima, very much for giving us this presentation. Chima has pasted his email address in the chat. So if you want further details or further questions, please, you can reach out to him on it. Thanks, everyone, for making it to today's live session, which we are really pleased about it. And sorry for also taking, I think today we are way